Hello friends, I am Chandan. Today's topic is steam table. Before steam table, we consider a process. Suppose you have some water. This water have the temperature that is 20 degrees Celsius. Suppose you want to convert this water to 150 degrees Celsius temperature steam. You convert this water to steam at 150 degrees Celsius temperature. Then at suppose there is a pressure that is constant pressure at constant pressure. Suppose pressure value 0.1013 megapascal. Now if you want to convert this 20 degrees Celsius temperature water to steam, there is some processes there. Suppose there is a water that have 20 degrees Celsius temperature. You apply some heat to this water. Due to this heat, you apply suppose Q1 amount of heat. Due to that heat, the water is converted to 100 degrees Celsius temperature water. Okay, the water is converted to 100 degrees Celsius temperature water. That means water and the temperature of water that is 100 degrees Celsius. Now when you apply extra heat, that is you apply Q2 amount of heat, due to this there is a phase change is there. We know that phase change is always happen at constant temperature, so there is it is converted to the steam, and the temperature of the steam that is 100 degrees Celsius. Okay, after that this steam, when you apply some amount of heat to this water, to this steam, suppose Q3 amount of heat you supply that, so that is why this is converted to steam. Basically this is superheated steam at 150 degrees Celsius temperature. Okay, in this way you can convert this 20 degrees Celsius temperature water to 150 degrees Celsius temperature steam. Now here Q1 and Q2 is a sensible heat, because here temperature is changing 20 degrees Celsius to 100 degrees Celsius, here 100 degrees Celsius to 150 degrees Celsius. So that is why this is Q1 and Q3 is the sensible heat, and here that is Q2, that is the latent heat. Now when you draw this process in TS diagram, TS that is temperature entropy diagram. Suppose this is the diagram, temperature, absolute temperature, and entropy, specific entropy, and you have 20 degrees Celsius temperature water. Suppose you have 20 degrees Celsius temperature water, 20 degrees Celsius, and you apply some amount of heat, that is why temperature increases. So here temperature increases, and the temperature is 100 degrees Celsius temperature. And the next, that is temperature is constant, and next we apply some amount of heat, that is why the temperature will be 150 degrees Celsius temperature. So here this is 150 degree Celsius temperature. Okay, now here you apply Q1 amount of heat, here you apply Q2 amount of heat, and here you apply Q3 amount of heat. Okay, so here there is a temperature increase, next temperature constant, and then temperature increase. Now so there is a vapor dome will be created. So this is the vapor dome, this is the vapor dome, this is the vapor dome. So in this vapor dome, before this dome, this is the liquid state, here this is the liquid region, and in this dome there is a liquid plus vapor region, you can say that wet region, and before this line, before this curve, this is vapor zone, and this curve here, this is the critical point, and here this curve here to here, this curve is known as saturated, this curve is known as saturated liquid line, saturated liquid line, and this here to here, this curve is known as saturated vapor line, okay. Now this is the critical point. In this critical point, remember this, that the critical point temperature T, that is 374 degrees Celsius, and critical point pressure 218 to 222 bar. So this is the value, you have to remember that. So Cp, critical point temperature, that is 374 degrees Celsius, and critical point pressure 218 bar to 222 bar. Now here, this is the saturated liquid line. With respect to this point, there is some properties is there, and you can find these properties by using steam table, okay. And with respect to this point, there is some properties is there, you can find this property by using steam table. Suppose this is the saturated liquid line, and in this saturated liquid line, with respect to this point, suppose you want to calculate the specific volume of this fluid. Basically, you can denote that F, specific volume of fluid. If you want to calculate, you can find this by using steam table. In this point, if you want to calculate this, suppose you want to calculate the internal energy, specific internal energy at fluid, you can calculate specific enthalpy of fluid, you can calculate specific entropy of fluid. Specific means per unit mass, okay. Specific means per unit mass. Now with respect to this point, you can calculate Vg, specific volume of vapor or gas, specific volume of gas, specific internal energy of gas, enthalpy, specific enthalpy of gas, specific entropy of gas, okay. By using steam table, you can find out this. Now this is the process. Now suppose I have the steam table. This is a steam table. I have, in this steam table, there is a saturated water temperature table. This is temperature table, metric unit, and there is a temperature is there in degree Celsius, and with respect to this temperature, the pressure is there. Pressure is in megapascal, okay. Pressure is in megapascal, and with respect to this temperature and pressure, the properties is there. This is the property, that is Vg, Vf, Vg, Uf, Ug, Hf, Hg, Sf, Sg, and this Hfg means Hg minus Hf. When you difference this value, Hg minus this value, you can get this value. This value minus this value, you can get this value. Basically, Hfg, that means Hg minus Hf. If Sfg is there, then the formula will be Sg minus Sf. Okay. Now if you want to find out these properties, suppose I want to find out this property with respect to this point where 20 degrees Celsius temperature water that is that with respect to 100 degrees Celsius temperature, with respect to 100 degrees Celsius, and pressure will be 0.1013. So here the pressure will be 0.1013 megapascal. So with respect to this point you have to calculate this value. Suppose, so here the temperature, boiling point temperature is 100 degrees Celsius. This boiling point temperature is 100 degrees Celsius temperature. This is known as also, this is known saturation temperature. Okay, this is the boiling point temperature. So with respect to this temperature you can calculate Vg value. So here suppose there is a 100 degrees Celsius temperature. Okay, this is the saturation temperature, and the pressure is 0.1013 megapascal. So here 0.1013 megapascal, but you can say that 1.013 bar, you can say that. So here this is 100 degrees Celsius temperature and pressure will be 0.1013, and with respect to this temperature there is a specific volume of fluid, that is 0.1014, specific volume of vapor, that is equal to 1.673, specific internal energy of fluid, that is equal to 418.9, specific internal energy of gas, that is 2506.5. unit is given meter cube per kg, kilojoule per kg, enthalpy kilojoule per kg, entropy kilojoule per kg Kelvin. Okay, now with respect to 100 degrees Celsius temperature, all the property here, the enthalpy that is of fluid 419.0, and enthalpy of gas, that is 2676.0, and if you minus is Hg minus Hf, then this value will come. Now specific entropy of fluid, that is 1.3071, specific entropy of gas, that is 7.3557. so Hg minus Sf, then you can get Sfg value 6.0486. in this way you can use the steam table. Okay, now suppose there is a saturation or temperature table, and there is a pressure table. Two table is there. There is a temperature table and pressure table. So this is the temperature table, and here this is the saturation water pressure table. Okay, now this is the saturation water temperature table. Okay, suppose 200 degrees Celsius temperature, saturation temperature 200 degree. With respect to this temperature, the pressure will be 1.554. Okay, and you can get this value, Vg value, Vf, Vg, Uf, Ug, Hf, Hg minus Hf, that is Hfg, and here Sf, specific entropy of fluid, specific entropy of gas, and you can get this value also. So in this way you can find, you can use the steam table. Okay, with respect to 200 degrees Celsius temperature. Now this steam table will ends in this point, that is 374.136, and the pressure will be 22.088. so this steam table ends in this section, because we know that the critical point temperature, that is 374 degrees Celsius, and pressure 218 to 222 bar. So that is why this steam table are ends in this position. So that is why that temperature, that is 374 point something, and this is megapascal, this pressure is in megapascal, so that is why 22 point, and if you convert this into bar, that is 220.88 bar. So that is why with respect to this point, with this you can calculate, we can get all the value of this steam table. Okay, so this is all about the steam table on temperature. This is the temperature table. Okay, now, and there's a saturation water pressure table is also there. In saturation water temperature table, first there is a temperature is there, and after that there is a pressure is there in megapascal. But in saturation water pressure table, there is a first pressure is there in megapascal, and after that there is a temperature is there. Okay, suppose you want to find the pressure, that is 0.1 megapascal, and with respect to this point, the boiling point temperature will be 99.6 degrees Celsius, and with respect to this point, you can get the value Vf, Vg, Uf, Ug, SF, HF, Hg, and this is the Hg minus HF, and this is SF, Sg, and this is Sg minus SF. Okay, so in this way you can find all the properties in steam table. Now suppose this steam table is in with this, that is 22.088 megapascal, that means 220.88 bar, and the temperature will 374 something. So this steam table will ends in this way. Here the steam table will ends. Now if you want to calculate with respect to this point, you can find the value of this here properties. Suppose there is 1 megapascal pressure. With 1 megapascal pressure, suppose there is a temperature, saturation temperature, that is 179.9. There is a specific there is a Vf value 0.001127, Vg 0.1944. Okay, now Uf, that is 761.7, Ug 2583.6, HF 762.8, HFG, that is 2.153.3, Hg 2778.1, SF, that is 2.1391, SFG, that is 4.4482, SG, that is 6.5873. In this way you can find this data from steam table. Okay, thank you.